Aloha and welcome. In this video, we're going to be talking about access control. Specifically, we're going to be talking about file system permissions, privileged access management, and conditional access. So we'll go ahead and open up our text. And we're looking here at chapter 2, section 14. So we're going to start with talking about file system permissions. We're going to start with the Linux operating system. So in Linux, you have a variety of options. When you go to check the contents of a directory, you can type in ls for list, and then you can type in space minus LA, and that's going to give you a listing, a detailed listing of all the files, directories, and permissions that you have in there. The first character you're going to see is a throwaway, and don't worry about that. That's just information on the type of the actual file. But the next 9 are going to be very important because you're going to have 3 sets of 3 letters or special characters, depending on what the permissions are set to. The first one is going to refer to the owner's permissions. The second 3 are going to refer to the group permissions, and the third one is going to refer to the everybody else, the other, or the what they call the world permissions. So those 3 characters are going to be either an R, a W, or an X. So R stands for read, W stands for write, and X stands for execute. So if you don't have one of those 3 permissions, then in the space of where the RWX are, and they go in the order of RWX, if you don't have that permission, you're going to have a hyphen there, or a minus, whatever you want to call it. So a file permission of R-X, that's going to mean that whichever it is, the user, the group, or the other, is if it has R-X, that means they have read permissions. They do not have write permissions, but they do have execute permissions. So if you have RW minus, then that means you have read, write, and you don't have executable. So if you look here at our table, you can see all the different permutations and combinations. No permissions is going to be 3 minuses there in a specific cluster of those 3 sets of permissions. So all minuses means no permissions. R hyphen hyphen read, hyphen W hyphen write. Execute is just going to be hyphen hyphen X. RW hyphen is read and write, but no execute. R hyphen X is going to be read and execute, but no write. And hyphen WX is going to be no read, but you can write and execute, which is kind of strange. And then you've got RWX, which is full everything. So in the next section, it talks about what I was mentioning, owner, group, and other. So when you do the LS, and if you do an L minus L or minus LA, you're going to get the full set of everything here. And this is shows you an example down here of what you've got. So we're going to go ahead and start this just to go through and look at one. So we've got hello.c as the file name over here. This is going to be your creation date here, size. So you know this was created February 6, 16 at 4:13 p.m. The size of it is 56,700 bytes, I believe. And then we've got over here, we've got our settings set up as for the first one, it's going to be the first one is the file type. Don't worry about that. Then we look at the RWX, RW hyphen, RW hyphen. So we know that we've got read, write, and execute for the user. We've got read, write, and no execute for the group. And then for other, we've got read, write, and no execute. And that's, the owner class has everything, the group, and other classes have read and write. So that's what we just said. So looking at the second one here, we can see that in the first 3, or after the hyphen, we've got read and write for the owner, no execute. We've got read only for the read only for both the group and other. And then if we go and then we look at weather.py, we've got read, write, and execute for the user. Or for the owner, we've got only execute for the group, and we've got read and execute for the other, for world, essentially. So you can go here, test out your knowledge of it. This is going to require you to really look into it and figure out what your permissions are. This will really solidify that in your mind. The next thing we're going to be talking about is Windows permissions. Windows has its own file permission systems. So we've got full control permission, which means user can read, write, modify, and delete a file, and it also can change the file's permissions. So you can change that as well. You can modify permissions. The second type of permission is modify permissions. That allows the user to read and modify a file. Uh, so then actually, I misread that. In modify permission, it's referring to you're able to read and modify the file, not modify the permissions. So read and execute permission, that's going to allow you to read and execute the file. Read permission is going to allow you to read the file only. Then write, and this is one to pay attention to, write is going to allow you to write to a file and to modify a file's permissions. So write also gives you the ability to modify the permissions. So you can write to it and you can also modify the permissions, okay? And then we've got questions about that. You're going to be asked a tricky question about write in there, I believe. Then we've got privileged access management. We talked about privileged accounts earlier. We talked about how we've got the root access and how root access is very important because root access gives you a lot of control that you really don't want to be using in a daily, day-to-day situation. So we want to limit our ability to work at this accelerated privilege level. So when we talk about privileged access management, PAM, it's also known as privileged identity management. It's a set of controls, tools, and processes for managing, securing, and monitoring a privileged account like root. So a privileged account is an account that has elevated access rights in the system. For example, super user, such as the administrator account in Windows or the root account in Linux and Unix. Those are privileged accounts. So because the privileged account has greater security permissions, there's a larger potential to cause harm, either intentionally or accidentally. You can do more than any other account type, so that's why we have to be careful with that. So a privileged account may have the authorization to override security controls and perform tasks such as configure networks, shut down systems, and provision accounts. That's why we really need to have these things under control, so not anybody can get access. Because if a hacker gets access, this is how they pivot and move throughout your systems. They can, create, privileges, create, access to other places, and they can move laterally throughout your entire network. So the management of a privileged account should ensure the principle of least privilege, which I mentioned in one of the last videos. So we want to make sure that the principle of least privilege is enforced, and the privilege of least privilege, the principle of least privilege, as I mentioned before, it means that you're only going to get the minimum access rights that you need to do your job. So you shouldn't have the ability to do anything more. If you're working on the database, you shouldn't also have access to configuring network devices and things like that. You should only be restricted to the things that you're supposed to be working on. And then we have mix and match for this and questions. Then we have conditional access here. So conditional access is access controlled based on a predefined access criteria or condition. So an access criteria may include a subject's geolocation, device type, IP address, or a device's security state, such as having an up-to-date antivirus signature file or the latest security patch. This should sound familiar. We talked about this in previous sections. So an access control device may include blocking, limiting, or allowing access to an object, or requiring the subject to complete multi-factor authentication or request the installation of a critical security patch on a device. We've talked about this as well. So conditional access is commonly used to enforce security policies. A system that supports conditional access analyzes real-time conditions and system security policies to make a security enforcement decision. So their example that they give here is that conditional access may be used to enforce a security policy that requires a user to complete a two-factor authentication before granting a user access to an accounting application. So their example is Microsoft Azure Active Directory and Intune support conditional access. So go ahead and answer the questions here. So yeah, and that's pretty much it for this section. So if you have any questions, this is pretty straightforward. The main thing to remember is your file system for the Linux file system. Know how these work. Know that you're going to have three sets of three plus that one file type marker in the beginning. So you're going to have 10 there, and it's going to look like down here. So it looks just like that. So go ahead. Make sure you understand what each one of those means. Go down here, understand the different types of permissions that you have in Windows. Remember that write permission also gives you the ability to modify a file's permissions. And then know that privilege access management, PAM or PIM, you're doing this because privileged accounts can cause the most damage, and you want to make sure that they are really controlled. And we go by the principle of least privilege so that you can only do just as much as you need to do in a system. And then there's the discussion of conditional access, which is restricting access based on things that we've talked about before, whether you've got the most up-to-date antivirus, or if you're coming from a certain place, or if you have met real-time conditions and things like that. So that's the crux of this section. It's not that heavy. So if you do have any questions about this, feel free to ask. I'd be happy to help you. Other than that, I'll see you in the next video. Aloha.